So last week we talked about genetic engineering. This week we're going to continue on with this theme of potentially horrifying, nature-altering, dystopic technologies and talk about geoengineering. So geoengineering, the basic idea is large-scale intentional alterations of the environment. There's a bunch of sort of proposals for this in the literature right now. And in this video, I'm just going to go through a few of them to give you like a sample and talk a little bit about their potential costs and benefits in terms of the practicalities of altering our environment. I'm not going to get too deep into the ethics of it in this video. That's the other video for this week. We'll talk about the readings, which discusses at length the kind of ethical implications of doing geoengineering in general. So that's the plan. Okay, so the why of geoengineering, I think, is pretty straightforward if you've been following the news at all. The evidence is overwhelming that humans have, for basically since industrialization, been having a huge impact on the environment and the climate in particular. We've been pumping out CO2 at an unimaginable rate. If you can see the little chart here, the environmental CO2 levels have spiked massively in the last 100 years. By itself, that would be plenty to be concerned about, but it's just one of a large number of indicators that tell us that the climate is changing at an incredibly frightening pace, and it's worrying altogether. I mean, I hope none of this is particularly news to you. So the obvious answer to the climate change problem is mitigation strategy. So find a way to, if you've got a problem, if you're causing a problem, the first step is to stop causing the problem. That seems obvious, right? So things like switching over to renewable energy, reducing our total energy use, looking for ways to minimize the impact of human activity in general are all crucially important mitigation strategies. As far as I know, nobody in the geoengineering discussion thinks that those are unimportant. I mean, everybody seems to agree mitigation strategies should be central to our response to climate change. The question is whether mitigation strategies are going to be sufficient to avoid global catastrophe over the next 100 years or so. It's unclear that that's an option at our current state. So we've entered a phase, the consensus seems to be, where a number of feedback loops have taken hold. So it might be the case that mitigation strategies are no longer sufficient because these feedback loops have started. For example, one particularly dramatic one is the release of methane from permafrost. So if you can see this image here, it's somebody's lighting the Arctic tundra on fire. Permafrost is defined as sort of ground that stays frozen all year round. A lot of what used to be permafrost is now melting. That ground has a whole bunch of sort of organic material in it, which is now decomposing, and the decomposition releases methane. That methane is coming up as bubbling out of lakes. If you cut a hole in some parts of the permafrost, you can light it on fire. And methane is an even more powerful greenhouse gas than carbon dioxide. So the heating has caused a bunch of methane to be released. The methane will cause heating, which causes more methane to be released. You get it. It's a feedback loop that has already started going off the rails, as it were. We're also seeing huge amounts of Arctic sea ice melting. Arctic sea ice is one of the things that kept our planet cool in the sense that it's very shiny. It's very reflective of light. So it bounces a lot of solar energy back into space. When that Arctic sea ice retreats, more of the solar energy is absorbed by the ocean and therefore stays in the planet. So that's another feedback loop. The warmer it gets, the less ice there is. The less ice there is, the warmer it gets. One more, sorry, this is grim, but this is why we need to think about geoengineering, because these feedback loops are happening now. The warming of the ocean means that the ocean can absorb a huge amount of carbon dioxide. There's huge amounts of carbon dioxide dissolved in the ocean water. But as it heats up, it can't dissolve as much CO2. So CO2 is no longer being sucked out of the air by the ocean. The warmer it gets, the less CO2 it contains. The less CO2 it holds in, the more is in the atmosphere, and the warmer it gets. Another feedback loop. So Mitigation strategies are unbelievably important if we're going to change course on climate change. But there's now nobody's, as far as I know, in the scholarly literature about this, arguing that we don't need mitigation strategies. However, there's a further debate about whether mitigation strategies, given the feedback loops that are already in place, already kind of started going, whether mitigation strategies are gonna do the trick. That's why, as readings for this week say, the last 10 years or so, this debate about geoengineering has really kind of hit the mainstream as people in climate science, looking at the numbers, start to think like, okay, even the most ambitious mitigation strategies, even if we stopped emitting all carbon today, those feedback loops would continue. And they look like they're bad enough to sort of cause trouble for the entire globe. So, okay, so what do we do? I don't know what we do, but here are a couple of things that people have suggested. So geoengineering strategies can broadly be separated into two types: solar radiation management and carbon reduction technologies. So I'll go through those sort of broad types of geoengineering, and then that'll be the end of this video. So let's start with solar radiation management. Okay, so the basic idea of solar radiation management is to somehow reduce the amount of sunlight that actually hits the Earth. That's obviously what's heating the planet up, the sun. And if you can find ways to either prevent that solar radiation from hitting the Earth or find ways to bounce it back more effectively, you can reduce the global temperature and mitigate a whole bunch of the bad effects of having put so much CO2 into the atmosphere. So here are some proposals. So this one is often described as the worst kind of geoengineering. It's like the crudest, simplest, and in many ways the worst suggestion that anybody's thought of. Stratospheric aerosol injection. So the basic picture here is you just have a bunch of airplanes or balloons, or some people have suggested like ordnance. So you like fire big military guns up into the air, and what they're spreading is a variety of particulates or gases, particularly things like sulfur. So sulfur compounds are pretty good at reflecting sunlight. And that would, so if you've got these, the most serious suggestion seems to be airplanes. You'd have a fleet of airplanes flying around, releasing sulfur particulates or sulfur gases into the upper atmosphere, as high up as you can get in the atmosphere. If you get something very high up, it sort of hangs around for years. And that would cause some of the sunlight to bounce back off into space, not be absorbed by the atmosphere, and therefore we would get a slight cooling effect. So the net effect of this process is predicted to be quite a lot like what happens when a volcano erupts. So when a volcano erupts, it releases huge amounts of sulfur gases and particulates into the atmosphere. Quite a lot of it goes into the upper atmosphere, and that has a clear, measurable impact on global temperature. After a huge volcano eruption, global temperature will take a little dip, and we can sort of see it pretty clearly in the records. So we know what happens when nature does this, something like this. It's also, in the pluses column for this one, it's also shockingly cheap. So this paper, there's a little citation for it right here. Stratospheric aerosol injection techniques and costs in the first 15 years of deployment suggests that you could get a reduction of like 0.2 degrees Kelvin, which is, it's not the entirety of what we would need in order to mitigate the effects of climate change, but it is a substantial chunk. They estimate that enough stratospheric aerosol injection to reduce the global mean temperature by 0.2 Kelvin would cost about $2 billion a year. And $1 billion, it sounds like a lot of money to me. To me personally, $2 billion would be quite a lot of money. But compare that to like the Ontario government's plan to spend about $15 billion a year over the next 3 years to combat COVID. Like $2 billion a year in the scale of things that we're talking about, like the scale of the costs of global climate change, $2 billion is hilariously cheap. It's ridiculously cheap. So those are sort of the pluses of this kind of the simplest possible version of geoengineering. Okay, but it comes with, there's a good reason why the people who are talking about this stuff consider this one of the worst options that we have. This is one of the worst ways that we have of geoengineering, because really serious questions about the side effects remain. So, for example, if you reduce the amount of sunlight, you make it harder to grow food, which we really need some of. I mean, you need food. And if you reduce the amount of sunlight hitting the earth by 1 or 2%, that makes it 1 or 2% harder to grow food. And that matters on a global scale. We don't know what else it would do. We don't know how it would change weather patterns. Like, we can make predictions, but we don't have a whole lot of confidence about what happens when you intervene on the climate in this way. So really serious questions exist about side effects of this. There's also the question of coming to a global agreement about exactly how much stratospheric aerosol injection you want to do, because different countries might have different opinions about what the right level is. Furthermore, where are you going to do it, right? Because it'll make a difference, how you deploy this sort of stuff. So it's a global scale intervention. When you put the stuff into the upper atmosphere, it kind of goes everywhere. It affects everybody on the planet, but different people will have different interests about exactly how much and where it should be deployed. So everybody in the whole world is either going to have to agree on this, or nations are going to take it into their own hands and just do whatever they feel like, which I don't think would be great for the kind of stability of the global or political order. So there's really, in almost all of these projects, there's really serious questions about how do we come to some kind of consensus about their deployment. That concern will run throughout. That's particularly an issue with stratospheric aerosol injection. There's also, with this technology, very specifically this technology, there's a kind of addiction that the planet gets to this. So if you've lowered the global mean temperature by, let's say, 0.2 or 0.5 of a degree using this technology, you have to keep doing it, because the effect of stopping doing it, well, like in a couple of years, most of it would have dispersed from the atmosphere, meaning you'd see a spike in like a couple of years of half a degree, which is, I know it doesn't sound like much, but in geological terms, that is unbelievably rapid. So all of the plants and animals who've been slowly adapting to cooler temperatures would be shocked with this kind of like quick whiplash-like effect on the climate if we just stop doing it. So if you start this, you'd better be committed to keeping doing it, and you better have a kind of global agreement that lets you decide how much of it you're going to do and where. So these are non-negligible issues with this technology that we really don't have good answers for at this point. Okay, a couple more solar radiation management ideas. Another proposal is to kind of try to increase the ice coverage in the Arctic. So if you can see this little picture here, there's a device that's used to pump Arctic sea ice up onto the ice-covered surface, and then once it's on the surface, it freezes, which increases the ice coverage. And ice is really good at reflecting sunlight, so that would increase the sort of amount of solar radiation that's bounced back into space. This one has been criticized for being pretty expensive for the benefits that it would produce. It turns out that the benefit of having more ice is not, like, this wouldn't be a game changer. This could be one thing that we do if we decide to do a kind of global geoengineering effort. This could be one part of it, but it's certainly not enough to kind of fix the problem. Definitely not none of these are enough to do it by itself, but this one's going to be a pretty small part of the story. Even smaller part of the story might be something like painting our roofs white or shiny or something like that. So in a cities tend to be hotter than the surrounding countryside because they absorb a lot of sun, right? If you got a bunch of black tar roofs, black tar is really efficient at grabbing that solar radiation and holding onto it. You can mitigate that by just painting roofs white, or if you paint the roads white, something like that, you can bounce a bunch of that energy back into space without it being absorbed. It's a thing that we could try. The amount of roof compared to the amount of non-roof surface on the entire planet is pretty lopsided. There's a lot more non-roof than roof, as you can imagine. So you're not really affecting very much of the surface of the planet. This kind of proposal is probably good for keeping cities a bit cooler, which means you can use less air conditioning, which means you use less electricity. So it's not nothing, but is not going to be a big part of the story. This is an image from Futurama. They literally had a space mirror in that show. So there's another set of suggestions, not necessarily just mirrors, but large space-based installations to either divert or sort of otherwise redirect some of the sunlight that would otherwise hit the Earth. That would certainly reduce the amount of sunlight hitting the Earth and therefore cool it. This is a misleading picture because it's just drops a huge shadow on one part of the planet. The more sophisticated proposals disperse some of the light rather than all of it in a specific location. So you get sort of less light overall. It's not like you'd have a humongous eclipse every 24 hours or something. So this is a pretty ambitious proposal. There's some benefits, like you don't have to keep spraying stuff up in the upper atmosphere to reduce the amount of sunlight that hits. It's a sort of more permanent solution. The downside is that we don't actually have the technology to do this right now. The idea has been proposed, but not an actual plan for how to do it. And it sounds like it would be pretty expensive. So this one's a little further out as an idea. Okay, so that was one class of geoengineering projects, the solar radiation management. The other class of projects are what are called carbon dioxide removal. So literally pulling carbon dioxide out of the air. As a side note, I find this image right here kind of funny. This image is exactly what we don't want to be in, the situation we don't want to be in. Because you got these theoretical carbon dioxide removers standing proudly in the foreground. And in the background, you've got like a bunch of cars and trucks and planes and factories all blasting out CO2. That is not where we want to be. We want to do the mitigation strategy first and foremost, and carbon dioxide removal kind of as necessary. But okay, so this is more like what carbon dioxide removal technology looks like today. It's a whole bunch of fans blasting air through sort of chemical collectors that through a chemical process pull carbon dioxide out of the air. There's a bunch of different chemical processes that are being discussed. The details don't matter too much for us, but the thing that does matter is that all of them take energy. So any of the carbon capture technologies that we got so far, none of them are passive. All of them require some kind of energy input to pull the carbon dioxide out of the air. This article from 2018 suggests that if we're really serious about carbon reduction technologies, carbon capture technologies, we could be using as much as a quarter of the global energy output by the year 2100 to do this carbon capture stuff. That's a lot of energy. And that's a gigantic gamble. I mean, if that's the route we're going to go down, it's a gigantic gamble because you have to build these machines and deploy them and get them going. So you're spending enormous amounts of energy before you find out whether it actually works or not. Presumably we know that it works on a small scale, but there's lots of processes that don't linearly scale up. And climate seems to be one of those things where very often the unexpected happens. So if the energy for producing them, like building these machines and deploying them and getting them running, is coming from non-renewable sources, that's even worse. I mean, we're really like putting ourselves back 2 steps to go 1 step forward. So the energy to run carbon capture. I mean, if sometime between here and the year 2100 we invent cheap unlimited fusion energy, then sure, this becomes viable. But currently, there's nothing that would power these at the scale that would be necessary to actually solve the problem for us as a single technology. If only we had some kind of self-sustaining process, some kind of process that pulls carbon dioxide out of the air using solar energy and stores it, maybe in some kind of like useful material even. That would be cool, right? Like if you could turn carbon dioxide into some kind of useful material, that would be really cool, wouldn't it? Oh yeah, okay, yeah, planting trees. That's an idea, right? So this is one of my favorite sort of proposals for geoengineering, just massive large-scale tree planting. There are a bunch of such projects ongoing in the world right now. I think it's one of the most interesting and potentially viable technologies for doing geoengineering, and it's partly because it's not really a technology, it's just trees. So estimates of how much of an impact this could make suggests that something like, so stopping deforestation continues. It has been slowing a little in recent decades, but it continues apace in some particular parts of the world. So slowing down or stopping deforestation, reversing it by planting a bunch more trees could contribute as much as like a third of the kind of impact that we need to keep ourselves below the kind of the target values of 2 Celsius increases or something like that. So this could be as much as a third of the story about managing climate change, and it's just trees. In 2019, during the Canadian federal election, Justin Trudeau and friends said that if they were reelected, they would plant 2 billion trees, which is a really impressive number of trees. That's a lot of trees. And they were in fact reelected. So as of November 2020, as I'm recording this video, they have planted so far 0 trees and allocated no money to the project. The Assistant Deputy Minister of the Canadian Forest Service says consultations are underway. So there's that. But it's a great idea, right? I think this is a brilliant idea. We just need to get going on. Okay, and just one more before we're done. Ocean fertilization. So this one is literally dumping a bunch of iron in the ocean. And I know that sounds bad, but hear me out. So iron is one of the limiting factors for the growth of phytoplankton. Phytoplankton are kind of the bottom of the ocean food chain. They're little tiny single-celled organisms that turn sunlight and carbon dioxide into cellulose. They grow their bodies like most other plants, like trees, like plants do, right? So there are these little microplants, if you want, and they form essentially the slightly larger things eat them, and then something slightly larger eats that. They form the bottom of the food chain in the ocean. They also, quite a lot of the time, when they die, they just sort of sink to the bottom and bring that captured carbon with them down to the bottom of the ocean floor. So if you add iron to the ocean, this line of thinking goes, you increase the amount of phytoplankton that grows. So you get what's called an algal bloom. And that not only captures a whole bunch of carbon, but sort of reinvigorates the ocean bioecosystem. That's the plan. And in fact, this was tried in 2012 on a small scale, but in 2012 in British Columbia in Canada, a company called Oceanus partnered with the Haida First Nation and dumped about 100 tons of iron into the waters controlled in their territory. This caused some consternation and quite a bit of controversy to say the least, but a large algal bloom did result. So there's a measurable increase in the amount of algae, and the salmon stocks did seem to do better in subsequent years than they had previously. Now, there is debate about a couple of things here. So, for example, did the increase in salmon stocks was that actually caused by the ocean fertilization project? Unclear. I mean, salmon stocks go up and down, so it's not obvious that just because they went up because of this. Further, it's not clear that you could scale this up. So again, 100 tons of iron is in the ocean, not a whole lot. And, you might say to yourself, okay, what happens when this scales up? And if you dumped 100 million tons of iron into the ocean, would other processes take hold that might be concerning? So this seems to have, as far as I've been looking for news about this ever since it happened. I was astonished when it happened in 2012. I've been following it ever since, looking for news of something terrible that happened as a result. And as far as I can tell, this worked great. I mean, it did exactly what the people said it did. And the company is currently trying to get governments in Chile to sort of try the project as well. So there's that. I mean, I don't know. It seems to have worked. Anyway. Okay, so this was just kind of a sampler pack of different proposals in the geoengineering literature right now. There's way more than what I've talked about, but that's the kind of overall idea, roughly separated into solar radiation management and carbon capture, carbon removal technologies. In the next video, we're going to talk about the ethics of geoengineering. Like, is this a good idea at all? And what can we say in general about whether it's moral to intervene in the climate in this large-scale way.